So you're back from our coffee break with the tutorial number 3, from static slicing to network slice as a service, the evolution of 5G networks customization. This tutorial will be presented by Professor Cristiano Bonato both from University of Vale do Rio dos Sinos, UNISINOS. Professor Both has been an associate professor at the University of Vale dos Sinos since 2019, working graduate programs in applied computing. He is also a visiting researcher at the State University of Campinas through the Smartness Engineering Research Center in partnership with Ericsson, and a consultant for the National Education Research Network, IRNP, in 5G, 6G, and Open RAN. Additionally, he is a researcher at the Inatel Competence Center in 5G and 6G networks, xGMobile. He earned his PhD in computer science from Federal University of Rio Grande do Sul in 2011, including research stay at the University of Pisa, and his master from PUC Rio Grande do Sul in 2003. Dr. Bolt coordinates the Innova Center of Excellence in 5G, 6G networks founded by FINAP, and contributes to several major projects supported by FAPESP, MCTI, and RNP, such as Porvir 5G and Brazil 6G Phase 3. Research focuses on open and disaggregated networks, especially Open RAN, along with virtualization, SDN, and AI-driven network intelligence. Internationally recognized, he has made significant contributions to wireless and mobile networks, reinforcing his role as a leading researcher in the next generation communication technologies. Professor Cristiano, the floor is yours. Thank you.
Thank you, Luciano. Thank you for opportunity. Thank you, Vanessa, for the organizing the workshop. Is very wonderful. Today, I discussion about the network slicing, and I, Gustavo, present the one overview and 2 demos for the static and the network slice as a service for present the evolution this topic. One briefly curriculums. I am a full professor for the UNISINOS and coordinated one project in the xGMobile. The name is considering the Nova Genesis in network slice as a service, and Gustavo is a postdoc research in the xGMobile, and your and ground is infrastructure as a service in the 5G and the beyond 5G or RAN and cloud computing. The agenda we organize in the 3 big topics. The first one we discussing about the mobile networks, considering the basic concepts, the background about the softwareization and the telecommunication, and we present one demo considering the static network slicing. And the second part, we discussion about the evolution for the 5G networks customizations. I present one briefly state of the art considering the network slicing, and we present our platform. The name is NASP, Network Slices as a Service platform, and Gustavo presenting the second demo considering the slices as a service. And finally, we show the work in progress. Okay. Normally, we study in the graduation the one approach considering the vertical approach, the different layers, the physical layers and the application layers. But now it's important we show the other perspective, considering the horizontal perspectives. Professor Lee present this perspective in your slides, considering the radio access network, the transport networks, and the core networks. In the Professor Lee presenting the transport in this part, I presented the transport in this part because I consider the one only operator. And a one only operator has one transport domain, considering the front haul, middle haul, back haul in the ORAN perspective. is important for is important for network slicing because we have many study, many research considering the network slicing and the one domain only. For example, many papers considering slicing and the run. The different research, the different topics considering only run, the core and the transport. We argue the end-to-end network slices is important. We consider the all domains because why we need to guarantee for the latency, for example, or the throughput. We need to consider this point of view. And one little background about the network slicing. We have more or less two options. The first one, we have one network slice considering only infrastructure. We have your infrastructure, and it don't sharing the infrastructure and the other slice. But we have the two options: the exclusively infrastructure for one slice is not common, but it's possible. Normally, use the one exclusively infrastructure for the specific applications for the requirement, strict requirements. And we has the second type of this license consider the sharing infrastructure. We have the many licenses considering the same infrastructures. In this case, we using the virtualization, the virtualization a lot. And in 2021, the GSMA published one paper considering the perspective for the future. And we define the three options for this license, considering the core, the run, and the transport in this timeline. And we define in this paper, considering the static network slicing, the dynamic network slicing, and the network slice as a service. In fact, we evolution in this timeline, but it's not exactly considering this timeline because, for example, today is not complete the evolution in 2024. We have many problems, many challenges considering this perspective. But in my point of view, it's very nice because we understood the different point of view considering the core, the run, the transport, and the three domains together. And it has one logical for the starting in the core, because in the core has the identification for the slicing protocols and the infrastructures. It's important that we have the one core that support this slicing. In the last generation, for the fourth generation and the others, not support one native characteristics for the slicing. And the 5G core has this. And it's normally we need to start in the progress to network slicing, considering the core first. After we investigating in the community for world investigation, the run slicing is push considering the 3GPP and or run. Many study, many research investigated the or run slicing. For example, considering the scheduler, considering the research allocation and the others. And finally, we need to integrate in the core in the run, considering the transport networks in the same operator. It's very important because we have the two domains, the core and the run, but it's important we integrate it for the transport. In this case, our run has many important because considering the disaggregation Gnode B, we have now agora RU, CU, EDU, and create the more specification transport network in this case. It's very important, but it's not finished this story, this evolution. We stayed in the continuing evolution in this part. And for example, in 5G from Brazil, we have one core in the operators, commercial operators in Brazil. We have the different cores and configuration in the static network parts. For example, one big operator from Brazil in the 5G start in the generation support the six only slicing. And the evolution core and the evolution run is usually support the more dynamic network license, and the future and the perspective, the operator and the tenants need to requirements is licensed as one servers. For example, one vertical applications need one specific case, one specific network. He request one is licensed, using this license, and the commission this license. This is one perspective for the future, considering the business, one new business model. I mentioned I request one is licensed, I decommission one is licensed. Okay, we have one life cycle network is licensed. It's very important for understand the resource allocations for the infrastructure, the physical infrastructure, because I am one operator, I have one physical infrastructure, but it's finite, not infinite. And we need to scheduling the request for this license, considering my demand, my resource allocations. It's important to understand the life cycle. And the life cycle has the first part of the life cycle is one preparations. For example, one operator, one slice as a service, for example, receive one template for, okay, I need one slice, and we specify details for this slice. And this detail is standardizations for one standardization of body. After this request, I am an operator. I activate or not. I have a research for accept the request or not. But I activate, and more important part is the operations. I supervision the quality of server, for example, this license and the other license. What interference the my license and the other license is important, because this license, the idea of this license is isolations, is the flexible, but I need to organize the supervisions for this license and the other license in my infrastructure. And I receive reports about the life, the good or not life for the mice license. Okay, I need more research, I need less research, the quality of the user is okay, is not okay. It's very important to receive reports. And in many cases, I need to modify my slice. Okay, the tenant requests one modify, or I am an operator modify the resource allocations, because I need the order slice and need to share in my infrastructure, and depend for the strategy, for the business, for the money or not. I need to consider in this perspective for the modify the slicing, considering my infrastructure. Finally, I deactivate and end my license, decommission the one's license. This is a typical life cycle, the one's license. And imagine I am a one operator. I have sent 2,000 license and need to organize and the orchestration of these licenses in the my infrastructure. This is possible today because we have the 5G core. Because the 5G core is flexible, the 5G core is using the software-based architectures and more flexible to organize, orchestrate this all life cycle for this life cycle. And in the release 15, 3GPP define one function for network slicing selection functions, specific for this license. In the first release for this 5G, define this slice, this functionality. This functionality is important to identify features for this license. The identification, the selecting, the protocol for information this license. Not the orchestration, because the orchestration is one level more high. Here, I has the two plan, for example, the data plan and the control plan. Usually, we instantiate the many slices, normally considering the data plan. But it's possible I create one slice and considering the data plan and more part for the control plan, or considering the one only core for the my slices. The 5G core is flexible, and the software is flexible to organize this slice and consider your demand. In this case, for example, I define one only core, but for one slice, I have the one GNODB and the one UPF for start the data plan in one slice. I duplicate these slices. I put more on one UPF in the other slices. I have one possibility for the configuration, the all type for this license, considering for the request for the my tenant. It's possible because the core is flexible. The core is more flexible for the other generation. And this functionality has information about the signal network slicing selection assistant information about the identification, the one slicing. For example, in this ID, we have the two parts. The first part, we have the 8 bits for the slicing service type. For the identify the type of the slicing, we have the 3 type of the server in the 5G, the broadband, the low latency, and the type massive communications. We have only 3 types for the slicing in the 5G. But I instantiate the many slices considering these 3 types. And we have more 24 bits for identification of the different slices. Okay, I have 3 types for this license, but many options for slice. The name is a network slice instantiates. I instantiate many slices considering my infrastructure, virtual infrastructure. We have other concepts. This is important because this is a concept, and Gustavo will show in the demo. We configure these informations considering in one virtual and softwareization infrastructure considering the Kubernetes. For example, is the SST1 is a one mobile broadband MBB type. The type, the number this slices is 111. And this is a security part for the identifications and the UE connected in this slice. Now we configure is dynamically in the first time statically, and for using the more automatization in these parts. Gustavo will show in your demo. The other part for the informations is the network slicing type. It's a one contract. Okay, one tenant requests me one slice. We need the tenant need to define the type for the slicing and the specification of the slice. We use the concept considering the slicing, the network slicing type. For example, this number SNSSAI is one pointer for the one contract definition for the tenants. We use in this identification the concepts in the practices in the concrete part. Is usually we think, okay, we have the telecommunication is evolution for the softwares is okay. I have many softwares now, but is a normally thing, okay, I use the cloud computing because I have one sharing infrastructure. I need to have more research because I need to allocate the research allocation considering the demand, the dynamically demand for the user. And I need to have more infrastructure, the physical infrastructure. Okay, in the add part, the infrastructure is finite. But considering the power, the CPU, and the memory, I have the cloud. It's possible I use the infrastructure for instantiate the many research considering the slice. It's not all, but one part for the infrastructure is possible. I use the cloud computing. And the other part, I use the physical only, or the add, depend for the demand for the users. But is normally to integrate the two big areas, the telecommunications areas and the network areas, working together to provide the different slices considering the horizontal scale and the vertical scale. In this context, Gustavo will show different tools. We use now Kubernetes, we use now Helm, we use many tools considering the technologies for the cloud computing native. In the standardization, what do you do? We have basically three views for the standardizations. For the GSMA, the focus is the service definition and orchestrations. This standardization body, the focus is, for example, the network slicing consumer, the use case and the requirement, the network slicing preparations, the onboard for considering the tenant perspective. These definitions is important for the specification and enabler the one infrastructure enable. This second part for the figure is more domain for the 3GPP. In the 3GPP, define the more specification considering the different domains, the core domain, the run domain, and the transport domain. Is more specific, is important part, we consider the translator. Because, okay, one tenant request megabits per second. Okay, I have one run domain. My research allocation is not megabits per second. I need to allocate the research blocks. I need to translate this request for this infrastructure research. It's important the part for the integrations, considering the translate for the different part for the end-to-end slice networks. And the ETSI is important to, the focus is implementation and deployment. Okay, the standardization is more specific for evaluation of candidate, aggregation with slicing or disaggregation with slicing, internal slicing, entity configurations, what configurations I need or not, subtemplates. Subtemplates is meaning to the different domains. Is ETSI defined is better. We have the three standardization body, and we work it together. For it's important because we need to define for the orchestration aligned to zero touch, for example, is one hot topic for the management. One closed loop management enable for the self-configuration, the more fast configuration, the more optimizations, and the AI or machine learning integration for proactive assurance considering the SLA. But in the first time we start the create one slicing in the fixed, in the static. We are more or less 3 years, 4 years. We create one slicing is static. It is one human need to configure all part for the networks for start the one slicing. For example, the manual provisioning, the fixed allocations. Okay, the life cycle for this license is fixed. I define the resource allocations, the start and this end in the same resource allocation. It's not change. It's okay, but not using the statistic for the using the resource allocation. It's possible I use the more intelligent resource allocation considering the different life cycle, the different resource. It's a challenge because it's low time to market. For example, the deployment has 1 day or 1 week for configuring the one slicing completely. Dependent for configuration, for example, in the bare metal configuration or the virtual configurations. And in the fact is not a life cycle management. We define one configurations and not change until they finish the configurations. Now, Gustavo present one network slice static, but he used the many tools considering the cloud the cloud computing, not bare metal configurations. Okay, and he used for the run. We use the simulations. We use the the simulation tools, but in laboratory we use in the real infrastructure, not in simulation. Okay, Gustavo, please.
Hi, as Cristiano say, my name is Gustavo. Now I will show the static deployment. The main target of this demo is show how manually is to deploy targeting in the core domain, in the hand domain. In this case, we not aboard transport domain. Let's go ahead. I will pause a few times during the presentation to explain the details. In this environment, we will use one Open 5GS course, SBA, one UA run sim to simulate the run. Why we choose these two? Because Open 5GS is more stable recently, and the UA run sim is working seamlessly with Open 5GS. The GTP tunnel don't have difficulty to stay up like we faced with 35GC several times.
All this is running a Kubernetes node, Cristiano say, and in a single node Kubernetes cluster. Yes.
I complement Gustavo. In this demo, we using the Open5GS, but we test in the other open source cores, for example, Free5DC and the OpenR interface. And the run and the UA simulation is same. For example, we implement one self simulation. The name is My5G Run Tester, and use two. We test the many tools considering this scenario.
We play again. The first thing is manual deployment of slides in the core. As I'm using a Kubernetes node, I need to forward the port of Open5GS front end to my local host, to Open5GS front end and create a subscriber. Basically here I'm copying IMSE information and the authentication information, subscriber key and the operator key, just to create one of my first slice that will have just one UE. This first slide I will create limited with 10 megabits per second, just to illustrate the difference between three slides that I will create. And I will put slice configuration. First is 1 and 1111 for SD and SSD. And the second is the same way with final 2. I will not define throughput limit to this guy. I will copy the authentication key and subscribe key. I put a higher limit because the limit will be the limitation of your used open source solutions. In this case, you will run SYN and Open5GS. This is second slice. Now I need to instantiate this same slice that I was creating the core in the run. First thing, I will deploy one run. This run consisted by one gnode B and one UE. It's not visually good, but basically here is the information of the UE and the slice. IMSC and SD and the SSD. I'm deployed the first slice. The pod was creating here. I will check in the pod logs to see GTP tunnel is up. So it's okay, I checked that. Now I will deploy the second slice with limited throughput. This second slice consisted two by one gnode B and one UE. I will check now if UE will up okay, and if GTP tunnel will okay too, because without GTP tunnel, data pane is not working. Will not work. A GTP tunnel of second slice is okay. Now I will check with throughput of if slice I was created using iPerf. I will start iPerf server on UPF. I will apply slice on run using Linux TC. It's a simple approach, but work because we will run not native support slice. I have the throughput limited 10 megabits. Is not visually okay here, but we will show on the Prometheus interface that was monitoring UPF container. This throughput is increasing because Prometheus takes some time to synchronize with the collected data.
This slice is limitation in 10 megabits per second.
This is the first slice. But our target here is just to demonstrate this manual processing that is not scalable in bigger network operators. I have one slice with 10 megabits, okay, functioning, the first slice. Now you show the second slice without limit. The limit will be my infrastructure and the softwares. In this case, I guess it will be the software used. I have more throughput. I will show again on Prometheus to facilitate visualization. I monitor UPF again. I guess we will reach 100 megabits and something like that.
In the second slice, and the limitation in the 10 megabits per second.
I go back again to the...
No, Gustavo, put in the Kubernetes part, please. No, more or less here. Okay, I discussion about this part. In the Kubernetes, we have the pods, and this part is all components for the core, for example, the UPF, the IMF, and the NSSF, and they all components stated here. And these configurations, we sharing the UPF. For example, Gustavo created the choose license and not instantiate the more one UPF that I show in my slides. In these demonstrations, we share all functionalities in the core, considering the two licenses. We instantiate the one infrastructure, and the sharing this infrastructure considering the choose license is more easy. And the other point is very easy because we associate the choose license considering the identifications for the core. But when we have the one real run radio access network or the transport, we need to associate the map, the one identification for this license, considering the run and considering the transport. For example, I prefer create one license and define one path for this license in the transport networks. I create in the second slice and I define the resource allocations different in the other slices. Is more complex. In these demonstrations, is very easy because we sharing the virtualized infrastructures is shared, completely shared. But in the experimental real, the complexity is more high. Okay. In the second part, we need to show in discussion the more customization infrastructure. It's not physical, not manually configurations. We need to evolution for the 5G, considering the more automatization, the more automatic. And the idea is provide one solutions, network slice as a service. What this evolution? Now we consider the all flexibility for the 5G. For example, the programmability, the dynamic service creation, using the more functionality for the 5G. And for example, the traditional static slices is restricted for the scalability, the agility, is not flexible. It's fixed. And the perspective for the GSMA is the future. We have the network slices as a servers enables on demand for the different tenants, because we have now the API based on customizations. We have the many tools for the provide one slices as a service. But we need to integration the all tools for the providers in the new business. In our opinion, a network as a service is a driving to the cloud native core is important, because we have one good tools for scalability, the vertical and the horizontal part for the core. It's not important. The core is possible to use the core in the cloud, not in the near for the user, for example. And using the virtualization, the NFV, a lot. For example, Gustavo showed the one completely virtualization infrastructure, but it's possible using the hardware infrastructure and the hybrido, one part for the physical infrastructure, other part for the virtualizations, and using the SDN a lot, because we need different controllers for the different domains. For example, I need one controller for the run, other controller for the transport, or the controller for the core, and the SDN provide these concepts for this part, the configurations. And more recently, AI for enabling the orchestrations has many papers about this, but in the practical and experimental is not much. We investigated for the state of the art, and we classify in the two parts for the literature. The first part, we analyzing the different projects. Have a lot of projects considering the network slice as a service. The big projects, for example, ONAP, the standardization project, for example, MANO, the projects more recently, for example, camera project I mentioned in the first day, and the other, the X project is one big consortium. There's many projects considering this approach, and has many literatures provide the new ideas, new evolutions considering these perspectives. We classify these works considering the beyond 5G AI, really, is more recently investigation for the AI. The project model, considering the standardization templates and models. For us, the architecture, the server-based architecture is very important for us, because we need to provide these licenses as a service for the tenants. The server automatization is important, because we need to zero touch. We need to configuration automatic. And considering the life cycle, the LC, a life cycle management, the management for the life cycle for any slices, and the one architecture, one platform considering the network slice as a service. And the view is possible. We analyze is not don't have one solution is ready for the market absorbs. We need to develop the solution considering this perspective a lot. Don't have today one solution already. We need to develop and consider in this context more investigation, more investment for this context. It's important we define the 3GPP view. The 3GPP view, the core networks is only identifier for the slice. It's not management, not orchestrations. The orchestrations is more high level. And we need to run management domain, transport management domain, and the core management domain for apply in different domains. This is a big pictures for the 3GPP. It's important we understand because we need to we define one platform, one solutions, considering this global view. Because, for example, the run is very big. The transport core is the transport domain is very big. We and in very different parts the different domains. Standardizations for the 3GPP, the focus is architectures. The ETSI, the focus, the zero touch, the NFV, the GSM, the focus is template for the tenants. I mentioned in the other slides. In the static is very limitations for is a fixed manual provider, poor for the resource allocations. It's not good solutions. The dynamic slice as a service is a good, but it's not as a service. I manage more slice and manage more my research, scalability, but not orchestration. They are solutions considering the 3 domain. And we have a good challenge, for example, business intended, considering, for example, GSM, and the technical configurations, considering the 3GPP, not speak the same language. We need to all translator for the all part, for the all infrastructure, for the has one platform, integration platform. In this case, the 3GPP define one global view. For example, the first part, we consider the communication management domain and the global management domain. This part for the orchestration is very important for the view, the all domain, and receive the one request for the one slice. Okay, one tenant, for example, the vehicular applications, the edge applications, the agriculture applications request one slicing. Imagine, for example, one agriculture needs to define one slicing for using the drone for one day. I define one slicing for the one day, and after I decommission. It's a dynamically, and the operator receive this request considering the templates for the GSMA. And the operators need to organize the infrastructure considering the all infrastructure, the run, transport, and the core. And we need 2 different controllers for the all domains. This is a global view for the 3GPP integrating a GSMA and ETSI. This part, we need to implement the one hierarchical orchestrations, the top level and the bottom level. And in this architecture, we need to integrate in the CD infrastructure as a code. Is the same story for the softwarization part, because it's more fast. I change my infrastructure as a service, virtual as a service. Telemetry drivers is very important because I need to understand what happened in my infrastructure for the change in the same time. and implement the closed loop quality assurance using the AI analytics for the combine the request and the SLA and my infrastructure for the different business. For example, my customer pay more or pay less. I provide more quality or less quality considering the different business, the different context. In this case, we propose the NASP, Network Slice as a Service platform. We have the building block. We have the three parts. The first part is a onboard. This part is more specific for the xGMA because we receive the requirements, the templates for the different tenants, and we translate the tenants considering my research, my infrastructure, and put the one catalog. Okay, I receive one request for the one new slice. I look at my infrastructures. Okay, I provide this slicing or not. Oh, I provide, but I changed my infrastructure. I put the one slice here, one other slice here. I moved my blocks for provide this new slices. Okay, considering the time is very important. We define these templates, the models, and that this part of the data management is very important because I receive the main informations, the main requires. I put the one database for. I use the database for improve my infrastructure. In the middle block is the orchestrations. It's a very same a 3GPP proposal. Okay, it's a CSMF, NSMF, and apply the global view, the orchestrations, and the three domains end-to-end slicing. And the other block is a quality assurance closed loop. This is more important for quality of service management. The data transmissions is a different data transmission in this part, in the research translate the on board. Because here I translate the information in the low level. In the research translation is more important for the high level translate. And the data aggregations, for example, one slice or two slices is I need to aggregation information for decide in the receive or not accept one new slice. For data aggregation, very important because I need to telemetry in data plan and control plan. More important in data plan. I need to have many informations for I use the informations using the AI model and training. And discovery the all options considering the research allocations. Now is the AI model and the training we define, we imagine, but really is not using now. Probably is a working group in the other part. Probably I need more one master degree or PhD student for investigating this part here. Okay. The prototype implementations using the cloud computing native tools. For example, deployment using Kubernetes in the core and the other parts. For example, okay, we have one monolithic run. Don't using the Kubernetes, but we use now we configure the one open run. Okay, we using the Kubernetes 2. We use the ONUS for the control of the transport domain. We need different controllers in different domains. for example, OpenRAN, we using the near real-time RIC, no real-time RIC controllers for the orchestration and management this domain. ONOS in the transport, in the core, using the Kubernetes only. The core, we use all the Free5GC and the Open5GS, and we use the simulation or not. Normally, for demonstrations, for the this part, we use the simulations, but we working now in the implementations for the experimental environment in this platform. NASP using the Helm and the YAML, using the language for the new language. For example, we use the Go. The more part for the NASP use the Go. The implementation using the REST, the JSON APIs for the intended basic architectures. And this platform supported the 3 types of the slicing. The low latency, the massive type communications, and the mobile broadband. This part, we have the 2 view of the deployment. In this part we define the definition for the contract. Okay, I received the one request for a slice. I need to define one SLA. This part is a fluxogram considering the contract, the SLA contract for the one new tenant. And this part is start, request for the new instance, new instance. For example, replic the one PDF or PDF, sorry, or GNOB, or configuring the resource allocations. This part is the contract, is more high level. This part is the request, the infrastructure is more low level. And the figures, now we configuration, the configuration for the transport the networks, today we use only VLANs. For example, we create one slicing when define one or more VLANs exclusively for these slices. Is ideal? Not. But in the first versions for the NASP, we define this because VLANs isolate the transport, the one path in this case. But in future, we not use only VLANs, but using the reprogrammability for the hardware, for example, to Fino, for example, Smart Mix, for guarantee the quality of servers in the transport network too, and use ONOS for the configure this part. In this state, we configure one slice and create for the specific slice different VLANs, one or more. Okay, the isolation and the transport only today using the VLANs, but we investigate other options in this case. In the core, you using the functionality native for the Free5GC. And the run, we using the apps and XApps, for example, considering the O-run. Or the monolithic run, it's more easy. We identify, we associate the identifier, the core slicing, with the base stations only. And the practice now, we investigation the associate the resource block for the specific slice. Okay, I create the one slice 1. The slice 1 has 10 megabits per second, the Gustavo show, and we calculate how many resource block I need to guarantee 10 megabits per second. I need 10 resource blocks. I reserve resource allocation 10 megabits per second, consider the 10 resource blocks. Depend for the numerology for the resource allocation for the run. The platform is flexible to configure the different options for the run, the transport, and the core, we change the one core or the core. The platform is flexible to change the different options. Gustavo, demonstrate the second part.
Now I will show the same slice creation that was did before, but now using our NAS platform. In this case, we will deploy one slice. Let's play to start showing the figure. We will deploy one slice in two domains, in brand domain, in the core domain. We will use our SMO NASP that we will show in few seconds. To deploy slice in the run, we will use RIC, non-RT RIC, and near-RT RIC. We are using the stack from Warrun software community. We basically NASP send to non-real-time RIC slice information based on GSMA specification. This convert this slice information into a slice policy that will need to be translated again in information that can be transferred through H2 interface to the run. In this case, we will run sim, but we are working hard to implement this in SRS run. In the another path, you need to create this slice in the first step in the Open 5GS core. You will run sim, be able to connect, and we don't need to do all that steps that we made before. We just need to open front end of NASPs.
Sorry, Gustavo. It's important we mentioned in this block we receive one GSM template for the one tenants. Is a human language, and we translate in this part. We translate this request for the one network language. For example, megabits per second, the identifier, specific identifier for the run. In the app, we put the app and the exap NASP, but the correctly is the app and exap slicing, for example. In this app, translate the information and calculate the research, using the research for these slices, and created one policy. Other translate, one translator, two translate, and the exap apply in the simulator infrastructure. In this case, we use we run sim for the simulation, but using this exap in the one SRRun stack is a work now. It's important we mentioned for we use the or run. We need to translate more information about the global architectures. When people ask me, it's important we use the app. It's possible we using the SMO directly the except. It's possible, but the SMO is more complex because I need to translate more information for the accepts. The ORRUN Alliance define the very different layers for the no real-time RIC, the new real-time RIC, and we use these definitions for the ORRUN Alliance. They put the different parts in the different moments. It's important because the no real-time RIC is has more time for decision, the seconds times, and the exaps don't have many times. With a thing, with execution. I think what the configuration de my run, and the exap execution considering the simulation or not, the stack, the radio stack.
Now let's deploy this one slice in the SMO app, NASP. First, you need to open the NASP platform front end. It's a simple prototype front end. we need to request a GSMA slice based on GSMA template. I put one name, can be test or something like that. I put a range of MSI that will be covered by this slice, and then I put the authentication info.
Well, it's important show this is a GSM request structure. It's a specific request for the GSMA. Is a different for the Camara project. For the Camara project is a same language, but the infrastructure is different. We need, for example, I using the platform considering the Camara project. We need to convert this request for the Camara project because in the GSM has more detail. In the Camara project is more specific. Okay, but it's possible because we change this part. Is change the part, but the SMO app need to understand the all tags.
Let's continue. In this case, I will create two users. I will increase downlink and uplink to be unlimited, basically.
Gustavo configure in manually, but the tools has one catalog for the other templates for the user. Okay, it's the same slice. I choose the same slice in the next step.
Yeah. This is basically the customized approach. We have in this platform we have a lot, but few templates ready to deploy. You need to have to know how. You don't need to know details about your request.
The NASP is not 0 touch, but 2 touch, 3 touch is okay.
Let's view, okay. It's not playing, so I'm request. Now I need to check on core if this WIS was created. So, NASP say that it was deployed okay. I will open 5GS to check if this was created. Oh. I have this UIs that was created using NASP. The information that was there is sliced, everything. So this demonstrates that NASP is integrated if you open 5GS. Now I will start traffic on this slice using UI run sim. Same approach before using iPerf. I summarize this part because we had seen before in the last video. UPF was receiving. Let's check front change. And throughput is generating. In this case, we integrated Grafana into NASP because Prometheus has a lot of things ready to use. Because Prometheus has a lot of dashboards ready to use, and we got and put here on NASP. We are working on logs and trace and everything to make the monitoring of the infrastructure. But is it?
We have the two visions, the operator vision and the tenant visions. Gustavo showed the operator visions. We have we show the always license. Gustavo created only 2 slices, but it's possible we see and management always license for the one operator. And I am in the other profile. I am a one tenant. I look the my license request and the accept and not accept and the control the all part for the management for this license. The idea here is the automatizations. The one is static slice as a service. The one static license for the one is license as a service. The one service for the different tenants.
Instead, I need to have one specialized team for each domain, for transport, for run, for core. I can deploy one slide with one guy controlling NASP. This is our main target.
Okay, go back. What we are investigating now, we have the two initiatives. Is the part for the no real-time rig, the new real-time rig is work completely full, because we has one except the slicing working, and we have the RAP working too. We investigate on this part now. For example, we change for the simulation part and they put the one open source solution, the SRR, and configure in the one real RU unit, radio unit. We use in the RNP infrastructure, considering the program Open Run Brazil. But Inatel give me one RU for I test, and the idea we test the one RU in the laboratory, considering this line. Is a good challenge because, for example, SRR has one service model, but we need to implement the other functionalities for the service model for the considering the more specializations slicing. For example, today the SRR has 3 types for the slicing: minimal, maximal, research blocks. But we need to investigate more details, more qualifications for the one is licensed for the provide one better guarantee of the service. The idea we change for the service model for to provide more quality of service in this licensing, considering the application, because Gustavo mentioned we received the one demand for the reality, the augmented reality. I need to provide the one good solution for the video on demand. It's okay, it's not go performance. And the other solution I have one PhD student in this part, and we have the other the PhD student in this part. The idea, we not use it only VLANs, but using the programmability in the transport. And we received the 2 Tofinos for the reconfigure the hardware for the guarantees the quality of service in the slice. Is because for the guarantee, for example, low latency, we need to change the queue for the transport networks. And other important part for the run and the transport, we need to associate the identification for the core in this part the networks. Okay, I create one slicing, I define one queue for the one to Fino switch. I need to associate this queue to Fino switch and my slice. And the other queue, I need to associate the other slice. I need to associate the identifier for the transport network, for the VLANs or the queues with my identifier for the slice, the core. It's the same approach in the slice. And the idea is guarantee the end-to-end network slice, because I guarantee for, okay, this identifier work in the core, work in the transport, you work in the run, and they isolate the traffic in the all domains. This is idea. Okay. This is a working in group, and my presentation is finished now. And I don't know, Gustavo, do you have more comments? And I received the questions and the comments for all.
Questions? Okay. I was sure about it.
Actually, first of all, congratulations. I think this is a incredible work because it's a demonstration of exactly what you need to do to make this happen. So integration with different planes. So and this is going to really good direction. So first, congratulations. Then a question. During all the workshop, there was a lot of presentations and talks about this AI run concept, right? And even when I presented on the first day, Professor Ian asked about the AI run implementation as a multi-agent concept. So you have multiple intelligent agents on the different parts of the network talking and converging to policies to implement something. For example, a network slice. And here you are going to a direction where you kind of actually you're proposing a new, with this SMO app, you are actually proposing a new intelligence layer. So it's like over the top of whatever you have on the RAN. It talks to the network intelligence on the RAN, but also already translates this also on the core and on the data transport network. Do you believe this would simplify to unify everything into a single, like hierarchical intelligence layer to control all the domains? Or for example, do you foresee exploring having different agents for each plane, and then they use, for example, MCP, like you explained, you use in the other project you explained? How do you see the implementing this distributed intelligence for getting this? This should be centralized. We should go multi-agent. Do we have any ideas on this?
Yes, thank you. Thank you. It's very nice questions. I have the one comment first. I convinced Gustavo to use the video. Gustavo preferred the hard demonstrations, but I convinced, oh, it's auditorium, it's not laboratory, it's better with 2 videos. But Gustavo preferred the hard demonstrations in the real part. The video is my my suggestion. And the question, the problem, we discussion the distribution system. It's a really situation now, and the AI agents. It's a tendency. It's not. It's a working investigate now. We have the 2 students, the master students, one they finish, one they start, and investigate for the AI agents. And the problem, the complexity is more high. It's not more simple. Or what do you think about the simplicity in the context? I don't know. Believe in the simplicity in the AI agent. I imagine is the more complexity, but the AI probably has one good solution in specific case. Is not in all cases. For example, we use LLM for the receive the request for the one slice. Is work, is good, but it's more simple. I put one form. Is more simple. But the tenant put in one text. Okay, but it's important. I need this. My other student, LLM is nice for the text, but in the low layer, it's not work. It's not good. I prefer machine learn. We need to design the different agents. It's not, for example, I use one agent considering LLM. Depends the problem, depend the solution. But the AI agent is, in my opinion, is a good solution because we have one distributed system. Thing in the agent distribution is nice, is good, but depended the project, the design for the agent, and the communication for the agent is the other problem. I test MCP, but the performance, I don't know. For the change the model in the control plan, it's okay, but in the low level, it's not good because I need more faster. The more the restrictions is more high. For example, in OpenRAN, in this part, it's not working good because the is more is not the performance not good. In the high level, it's okay. So I imagine in the future we use the many AI agent, but depend the design project depend the problem, depend the what specific. Sure.
Do you considering incorporating other planes? Okay, we have the core, we have the data transport, we have the RAN. For example, do you consider incorporating the cloud domain? So, for example, you could also incorporate whether you're going to use the edge, you're going to use regional, and also maybe the energy domain. So, whether you're going to use the solar power, whether you're going to switch to the public distribution of, so you can also talk to the energy planes. And do you consider to expand this to other domains as well?
Yes, the domain has the challenge difference. For example, the transportation domain, the problem is the time. We have the milliseconds for the receiving the informations. It's a good problem here. In this domain, we investigation federated learning because we put the one agent here in this suite, but we need to orchestration the suite considering the all agents for the transport. It's a one approach. In the run domain is a different approach because it's more. We need to, for example, energy. We need to optimize, and the hardware is a lot. The agent is a completely different for the transport networks, but it's okay for research. It's okay for the implementations. But do you need to consider the different tools and the different techniques for the different domains? In my opinion, one domain probably using the one technology for building, design one agent, and the other domain we need the completely different design for the other agents, and we need to integrate in the all. This platform is nice in my opinion because it's flexible. It's not the performance is more high, but we have one platform with integration all and the flexible for to change the end toys.
Any other question? I do have one. I was trying to hold myself. But you are navigating several projects, right? You have knowledge of the smartness project, Samurai project, Brazil 6G, and xGMobile. Do you think that you can bridge all the initiatives in terms of the core network and have one solution for all the projects?
A good question. All projects the focus is the telecommunications. It is the all projects that we using the open source, but it's not national open source. We using the global open source. I discussion my other page is a possible to develop, for example, not the core, but the radio stack, because, for example, the open source we have two stack only open source, and we have in Brazil we have the specific case, for example, the agriculture is a possible has opportunity in this part for the radio stack. In the core, I think the same, has opportunity. The problem, I mentioned Kleber. He's a big layer for the code. Is the code is not easy, and we need to many time and budget for to develop the one core on the project for integration the all in Brazil. For example, I mentioned the SRRun. SRRun changed the name and received the U.S. government one budget is big budget for improved the stack for the open source stack. We have many projects, but don't have one budget good for develop one solution, for example, core or stack in this context. But we try, we using this search for the investigation in the try. The Samurai project specifically, the idea is integration, the all part for the network, considering the focus in the core, but develop the one new core, the project, the one new core, the 60 the core, for example, is not easy. It has many people's, many research.
More close that we more close that we was one tester. One tester is the more close that we go close to your requirement. One tester is one run simulator, but one tester currently is not maintained. So I try to use a one tester here, but it's not being maintained for anyone and it not to work. I guess the challenge is not develop but maintain.
The 5 years ago, Kleber and I proposed the one new tester, the My5G tester, and it's very nice. Many people use the HP create one fork for our project, and many people using the fork is not our project. And what problem? Not problem. We not continue developing. Don't have a student for develop more. Don't have a budget for develop more. I don't know exactly, but we don't. I have one problem too because I don't continue this project because it has other projects. It's we don't have one culture for the maintains the software in Brazil. The long time ago, is I don't know exactly the culture, but is the one big project in Brazil the long time ago is a Lua, the language. It's a nice example, but it's a one only.
I guess you have to change the reality of long-term research. And I think Embrapi is changing that with the competence centers. Now you're talking about 30 years, not about 3 years. So it's a good pass.
Nice.
Okay, thank you very much, Professor.
Thank you.
Okay, so with that, we can close our 30 days. So we are closing actually the workshop today. It has been a very long week with several presentations And today was not different. We start the day with a very good description about how Embrapi is helping to develop the network here in Brazil. You had a very clear view about what Embrapi unit is and what a competence center is, what are the difference between them and how they can interact. So it was very nice to understand the difference, and also was very nice to see how far the competence centers have been gone with just 2 years of development. Later, we saw how generative AI can provide solutions for immersive technology. And you see that there's a huge investment in this area. A lot of companies are betting on creating new competence, new professionals in this area. And I think it's a very fertile field for new professionals in the future. Also, you have a very clear view of the Open RAN projects that are running at CPQD with the XCOM Competence Center. And then we saw a startup that is going to Barcelona to show that it's possible to use NB-IoT of no-terrestrial network to track animals in the sea. After lunch, you had our keynote from the day with ultra-reliable low latency for 5G and beyond. We saw that there are huge demand for low latency communications and how hard it is to provide that, considering all the delays that happens in the network. And we close the day today with this amazing talk about how network slicing can be providing a new horizon for future 5G networks. So I would like to thank all the presenters that came here in Santa Rita, especially the international ones that made a huge flight to be here. Also, I'd like to thank all the attendees that have been here in your auditorium during the day, and also for those that are following our transmissions via our social media. It was a huge pleasure to hold this workshop. It's for sure it's not the last one. Next year, you're going to have more results, more research, and more interaction to do, and properly more collaborations. Thank you very much, and I hope to see you next year. Thank you.